Today we're going to be looking at the 2016 December Gold Question Cow Checklist. So in this question, Farmer John has two main breeds of cows, Holsteins and Gurneys. So what's going to happen is he's going to start the tour at the first Holstein and end at the last Holstein. So this part is going to be important. And what he's going to do is he's going to visit every cow on the way, and he's going to visit them in the order that they're numbered. So we have two lists of the Holsteins and the Gurneys, and Farmer John is going to move, and we want to find the minimum amount of energy required to visit all his cows. So the algorithm we're going to be using for this question is going to be dynamic programming. So what we're actually going to do is we're going to have a three-dimensional DP. And for this DP, what we're going to do is we're going to have a couple values. So this question is pretty similar to a question we did last time. I'll link it at the end of the video. But what's basically going to happen is we're going to have two main lists of cows we're going to have to go through. We have the H cows and then we have the G cows. So what we're actually going to do is we're going to store these as two separate lists. And then for our DP state, we're going to have the current index in the H index we're on, and then the current index of the G list that we're on. So in this way, we'll basically be able to tell which farms we visited in what order. And then since if we visited the H and the G cows, there is still a difference on whether or not we are on the H or the G cow. We're going to have a 0-1 value that basically tells us whether or not we are currently at the H farm or the G farm. So what we're going to do is we're going to store the minimum distance possible. And so what we're going to do is for our transition, we're going to have dp ij, and then let's say for the sake of this example, 0. We're just going to make it the min of dp I minus 1, j 0, or dp I minus 1, j 1. And then we're going to add either the distance between the H cow and the previous H cow or the H cow and the previous G cow. And then if we were doing dpij1, so in the case of dpij0, what we're doing is we're moving the I or the H cow. So we're going to be moving the cow here, so we're going to need dpi minus 1. But once this becomes 1, so let's say we have this instead is dp ij1. Our transition is just going to be dpi, and then since we already visited the I cow, and right now we're moving the J cow because we're at the current farm in index J, we're going to do j minus 1 and then 0, dp I j minus 1, 1, and then plus the distances between the two. And then so in this way, at the very end, we're just going to output dph g 0 because the problem specifies that we're going to need to end up here. So let's go look at the code for this question. So I've set up the program here a bit. I have typedef long as LL, and then F and S as first and second. So anytime you see .s or .f, it means .first and .second. So the first thing we're going to do is we're going to read in the input, and I'm going to make my input 1 based because it's easier for DP. So I'm going to read in H and G, and then I'm going to read in the respective lists as the H cows and the G cows. So the next thing I'm going to do is I'm basically going to set up my DP. So there probably are faster ways of doing this, but in this case I'm going to take my DP and I'm just going to set every value to the maximum value stated in the question. So I'm going to set up my base cases here. So since we know we're going to start at an H cow farm, we're going to have dp100, or H cow farm currently at the H cow farm, as 0, so this is just our starting location. And then we're going to set 111, which is basically saying we started here, then we went here, and we are currently at the G cow farm, as distance between the H cow and the G cows. So I'm going to set up my distance function here. It's pretty simple. It's just going to be your standard x minus x squared, y minus y squared. So the next thing we're going to do is we're going to iterate through the DP. So there are a couple base cases. I'm just going to go through, I'm going to start from 0 and go to h plus 1 or g plus 1. So if I and j are both 1, or if I is 1 and j is 0, I'm going to continue because we already set up the only two possible cases here. So in any other case, this just wouldn't be valid because we can only start here or here. So the next thing we're going to do is if I is greater than 0, I'm just going to assume that there is another HCow farm. So I'm going to go to DP ij0. So I'm currently at an HCow farm. And then I'm going to check DP I-1, 0, and 1 plus distance, just like we talked about. And then we're going to do the same thing we described in the code. So we're going to do DP ij-1, 1, DP ij-1, 0, and then we're going to add the two distances. And that's pretty much the main idea of the DP. So for each one, we are going to basically check to see if there is a previous cow. If there is, what I'm going to do is I'm just going to check to see the two different possible distances. So I'm either going to go from HCow's I from HCow's I-1 or go from GCow's J. And then the same thing for the reverse. And then at the very end, we're just going to output DP HG0. And that's the end of our program.